This one you're going to want to pause and look at for a moment, when you try it. I've made a list of 5 things here. The magnitude of F net, the direction of F net, and the angle of the net force with WRT means with respect to the path of the object, and C means constant, delta means changing. So here we have constant, 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 changing, constant, changing, constant, changing, constant, constant, changing, changing, constant for E. And we have 3 cases here. A box sliding down an inclined plane. We can put friction on it, won't change our answer. And we have an object in orbit around a planet and a trajectory problem where the object lands at the same height it takes off. Pause it, give it a try. Which letter is correct for each of these cases? Okay, I'll assume that you gave it a little bit of thought. And as the object moves down the inclined plane, this is the direction of motion, and the net force would be whatever force is pulling it down the inclined plane minus the friction force. So the net force acting in the direction of the motion, so the magnitude of F net will not be changing. We're not pushing it or pulling it, and gravity doesn't change, right? Here's the normal force. Here's mg sine theta. Here's F friction. So F net is the difference of those, and it stays constant. How about the direction of F net? It doesn't change either. It remains pointed down the inclined plane. And the angle with respect to the path, it's aimed down the inclined plane. So we're looking for constant, constant, constant. And that'd be A. 2, we have an object with a centripetal force F. So the F net acting remains constant. F centripetal is constant. It's the force of gravity, which is m over times g over r squared. So the magnitude of F net doesn't change. It's going to remain constant, which eliminates these guys and brings us to these 3. The direction of F net is changing. So I'm looking for constant and delta. Starting with constant, moving to delta. I really don't even have to see whether the angle with respect to the path is constant, but it is. It's at 90 degrees, but I don't have to go through with that because I know I wanted constant and delta. So constant and delta was C. And then the last problem, which is the shooting at and landing at the same distance, a projectile, we want to know the magnitude of F net. The magnitude of F net is constant downwards, so I want a constant. I like these 3 so far. And the direction of F net, it's not changing, so constant, constant, like in this one and this one. And now I have to decide about the angle of F net with respect to the path. Well, the path is changing, so here is the angle between them, but that changes at the top, so I want constant, constant delta. Constant, constant delta looks a lot like B, so I'm taking B. There you have an example of analyzing some lab data or some kind of data to arrive at your answer, but ask yourself the questions and eliminate answers that are not correct as you go. You may find after just 2 of these that you don't even need to find the 3rd, and that's an important point. Don't waste time finding stuff you don't need because there's no answer there that would match it if you found something. So once you get the first 2, it doesn't matter because there is no other one that has constant delta, for example. So constant delta, if you get constant delta, you don't need to even check the angle because you know it's C, as we did in number 2.